Welcome to Ask and Learn.
We want to calculate the change in entropy, delta S, that results in the freezing of potassium. When we freeze a substance, we go from a liquid state to a solid state. We are given a value for the temperature and the delta H of fusion for this process, and we know that for phase changes that the change in Gibbs free energy, delta G, will be equal to 0 at constant temperatures and pressures. So now we have everything that we need from this equation to solve for delta S. And so we can rearrange that equation to form an expression for delta S to be delta G minus delta H divided by negative T. And now we plug in everything that we know. See that delta S equals delta G, which is, again, 0 for phase changes. Then we subtract that given delta H of fusion, 2.39 kilojoules per mole. And then we divide that by the negative of the given temperature, which when we convert it into Kelvin, comes out to 336.7. And so our units for delta S, the change in entropy, will be kilojoules per mole times Kelvin. And if we multiply our answer by 1,000, we can get it in units of joules per mole Kelvin. When we do that, we see that we get about 7.10 joules per mole times Kelvin. But remember, this is for the freezing of 1 mole of potassium. And in this problem, we are interested in the change in entropy for the freezing of 0.2 moles of potassium. So in order to find that total change in entropy, we multiply the change in entropy for 1 mole by that quantity N of 0.2 moles. So that's 0.200 moles times 7.10 joules per mole times Kelvin. So the units of moles cancel out. So we're left with total change in entropy units of joules per Kelvin. We get a final answer of delta S equals 1.4 joules per Kelvin.